machine learning systems, it's easy to focus only on the model. But in practice, what really matters is the architecture around it. So in this video, I'll walk you through a phishing detection ML system I built and how the layers work together. This system is structured into clear layers: storage, data ingestion, training, inference, CI/CD, and monitoring. And tying all of these together, we have an orchestration layer using Apache Airflow. So let's go through this flow step by step. We start with the storage layer. Raw data is stored in MongoDB. This gives us the flexibility when handling evolving or semi-structured data. So once the data is processed, it moves into Amazon S3. So as S3 acts as the central storage for processed data, model artifacts like that. So we separate this raw and processed data clearly. Next is the data ingestion pipeline. This is orchestrated using Airflow. So instead of running scripts manually, we define workflows that pull data from MongoDB, validate it, and push processed data into S3 buckets. These workflows are scheduled and monitored, which makes the pipeline very reliable. And the ingestion jobs themselves run inside Docker containers, so execution stays very consistent. Then comes the ML training pipeline. Again, this is triggered through Airflow. This includes data transformation and model training. For experiment tracking, I use ML flow with GitHub. This allows us to track parameters, metrics, and different model versions. So every experiment is reproducible and comparable. Once the best model is selected, it is stored in a S3 bucket. For serving predictions, we move to the inference layer. The application is containerized using Docker and exposed through a fast API service. The Docker image is stored in Amazon ECR. Then an EC2 instance pulls that image and runs the service. So this allows real-time predictions through a fast API endpoint. Finally, we have the monitoring layer. This includes drift tracking, model performance monitoring, and a dashboard built using Power BI to track and monitor these performance. So this helps us to track how the model behaves over time, and it ensures it continues to perform well in production. To automate everything, I use GitHub Actions. Whenever code is updated, pipelines are triggered, builds are created, and deployments are automated. So Airflow then uses these updated images when running its pipelines. What makes this system work well is how responsibilities are clearly separated and connected through orchestration. So Airflow is to coordinate the entire pipeline. MongoDB is for raw data, and S3 is for processed data and models. ML flow is to track experiments. Docker is to ensure the consistency across environments, and CI/CD is for automation. EC2 is for serving the predictions, and monitoring is for the track performance. So yeah, I have shared the full implementation in the GitHub repo. So if you are building machine learning systems, thinking in terms of layers like this makes a very big difference. Let me know how you would design this differently.